Well, hello again. In our previous 6 or so episodes, we looked at the inner planets of our solar system, that being Mercury, Venus, the Earth. We also included Mars. We looked at the Moon, and over 2 episodes talked about the efforts it took to get man on the Moon. So tonight we're going to discuss the other half of our solar system. And this half is huge. The distances from the Sun to the other planets are huge. The distances between the other 4 planets are huge. And those 4 planets are giants. So we're going to look at that tonight. I'm Bretton Bailey, and this is Our Night Sky. So now we're going to talk about the 4 giant planets of our solar system, and again, they're the furthest out. We don't know much about them because they are so remote. It's been difficult getting any kind of vehicles out there to study them to any great depth. But we have had some success there. We've had about 4 or 5 that I can think of right now: Voyager 1 and 2, Cassini, and Juno. Mostly what they were able to manage was orbiting and photographing Jupiter and Saturn. They basically did flybys of the furthest 2, Uranus and Neptune. And you'll see as we go along some of the fabulous photographs of each of those planets. Now, as I mentioned in the introduction, these planets are very, very remote. Neptune is the farthest one out at over 4.5 billion kilometers. Jupiter itself is relatively near. It's only 778 million kilometers away from the Sun. In fact, it takes sunlight 42.7 minutes to reach Jupiter. That's moving at light speed. That's pretty damn quick. A year on Jupiter is equal to 11.9 years on Earth, and 1 day is equal to 10 hours on Earth. So Jupiter rotates on its axis very, very quickly, especially considering the size of the planet. The gravitational force on Jupiter is about 2.5 that of Earth. So if you weighed 100 kilograms on Earth, you'd weigh 250 kilograms on Jupiter. Right now, the most distinguishing feature of Jupiter is its giant red spot, or the Great Red Spot as it's known. It's a huge storm, and we have an opportunity now to take a look at how that Great Red Spot formed, because there's another one forming not too far away from it. The storm has been growing since 1998, when 2 smaller white storms merged. And these 3 white storms were first noticed in 1930, but they merged. 2 of them merged in 1998, and then they merged with the 3rd one in the year 2000. And 5 years after that, 2005, it began to take on the red color that the Great Red Spot has. So now it's known as the Little Red Spot. Both storms are spinning cyclonically, meaning they're spinning the same direction our hurricanes do, so they're anti-clockwise. But scientists have determined that the Little Red Spot is growing and will eventually merge with the Great Red Spot and become an even larger, more gigantic storm. The next feature that makes up the visual impression of Jupiter are the bands. There are white and dark reddish-brown bands that run parallel to Jupiter's equator, and each band moves in opposition from the next one to it. So the white bands all move in one direction, the red bands move in the opposite direction, and they're moving at tremendous speeds. Jupiter, to its credit, has also been photographed since man has been able to watch it closely with satellites and probes and earthbound telescopes. It got struck by a large meteor once, and you'll see that there's just a single black dot bursting through the atmospheric surface of Jupiter. But in July of 1994, an inbound comet called Shoemaker-Levy 9 was attracted into Jupiter's gravitational field, which caused the comet to break apart into about 21 pieces. And over 6 days in July, they all impacted in a line along the southern hemisphere of Jupiter, you'll see up here. The next planet in line orbits the Sun at a distance of 1,466,662,000 kilometers from the Sun. Saturn is number 2. But what makes it magnificent to look at are its rings. But fortunately for us, the probes that we've been able to send out to take a look at the last 4 planets have been able to reveal something that astronomers didn't anticipate. Saturn is not the only one with rings. All other 3 planets out there all have rings. Now, the rings aren't as spectacular as Saturn's rings, which are largely made of, ground up rocks and ice. But the planets that also have rings, Jupiter, Uranus, and Neptune, the rings are not as complicated. They have fewer rings, and they're not as dense as Saturn's rings. So they don't reflect enough light that we can see them through telescopes. We really had to be able to cruise on out there with probes and photograph them there. But Saturn's rings are really quite spectacular. Like Jupiter, the atmosphere of Saturn is largely hydrogen in the high 80%. There is another concentration of helium, and at the very end of the scale are about 1% of just mixed gases. And most of that's going to be true for the other 2 planets as well. But it takes sunlight 83.2 minutes to get from the Sun to Saturn. Saturn receives about 10% of the sunlight that we enjoy on Earth. Now, that's not an awful lot of heat to warm up Jupiter and Saturn, but both those planets have very large cores, and like Jupiter, Saturn spins axial. It has an axial rotation that it stays about 10 Earth hours. So both planets spin very, very fast. Now, Saturn is not just famous for its spectacular rings, but it also has 82 moons, the highest number of moons in our solar system. Jupiter has 79. And a lot of these might have been Trojans or asteroids from Jupiter's nearby asteroid belt that were attracted and gathered into orbit by the magnetic and gravitational fields of the planets. That's the reason why they say there's only about 150, 160 moons out there in our solar system. But when they do get these others classified, there will be a total of 211. The last 2 planets in our solar system are referred to as the ice giants. They're both made of high amounts of hydrogen, into the high 90% range. They have a little bit of helium, and then 1 to 1.5% of their total gas composition is methane gas. And that gives these 2 planets a lovely bluish color. And as I said, not much is known about these planets. We've observed them by telescopes from here. They are the only planets in our solar system that are typically not visible to the naked eye. You need to have a telescope to be able to look at them. Both these planets were visited only by Voyager 2. That was one of the probes that was able to send back the photographs of both the planets so we could see what the outer layer of the planets looked like. And they're both a blue color. But we can also see the rings. Now, Uranus has 13 rings and 27 moons. Neptune has about 5 rings and around 14 moons. So even those 2 planets, which are about 4 times the size of planet Earth, they still have many, many more moons than what Earth does. So they help bring that number of total moons up to 211. Now, to give you an idea of how far away Uranus is, it's 2,807,000,000 kilometers from our Sun. It takes sunlight 164.5 minutes, which is nearly 2.7 hours. At the speed of light, that is a huge distance. So Uranus was the first planet discovered with the aid of a telescope in 1781. And since that time, being observed by man and many astronomers all around the world, from 1781, it had completed its first observed rotation around the Sun in 1949. That's a long time. That is an extremely long orbit. Largely hydrogen, about 80%, with 15 to 19% helium, and the balance being methane gas. Uranus and Neptune are about the same size, and as I mentioned before, they're about 4 times the diameter of Earth. Earth was a large apple, a little bigger than my fist. Uranus and Neptune would be about the size of a basketball. Neptune is 30.1 astronomical units from the Sun. And again, an astronomical unit is a means of measuring things within our solar system based on the distance of the Earth from the Sun. So an astronomical unit is 155 million kilometers, the distance from the Sun to the Earth. Neptune is 30 of those. Or in other words, Neptune is 4,503,443,000 kilometers from the Sun. That is huge. Neptune has 5 faint rings, and one day on Neptune is only 16 hours of Earth time. And since its discovery in 1846, its first observed orbit, just one single orbit, was completed in 2011. That is an enormous amount of time. Now, Neptune is very far away. Neptune is about twice the distance from the Sun that Uranus is. Neptune is 4,503,000,000 kilometers from the Sun. Sunlight takes 248.9 minutes to get from the Sun to Neptune. Just a little over 4 hours at light speed. I just can't imagine that. That distance is absolutely huge. So until we meet each other again, take care of yourself, look out for your neighbors, go on outside and enjoy our night sky. Thank you for dropping by. I am Breton Bailey, and we'll see you again soon on Our Night Sky.